Welcome to another coding tutorial, and in today's video, I'm going to introduce you to a physics library called matter.js. I always like to start my video by telling you the why behind the tutorial, and that is because I think it gives you a better idea of how I usually find my ideas. And many of my ideas usually start with me being inspired by a specific thing, and this tutorial is no exception. I was inspired by a project called AnyPixel, created by Google Creative Lab. It is an open source software and hardware library for creating interactive displays. I've known about this project since its release, but only this past summer that I got to play around with their version of an interactive display being installed at the Google New York office. It was very fun to play with, and as you can see from the video here, I was creating a bunch of balls by clicking on the buttons. The longer I held onto the button, the bigger the ball got. And as I released the button, then the ball just flew off in a random direction. And then the ball collided with the existing one inside this container. And I have done a coding math video and also a few coding tutorials on collision detection already, but they are quite basic. Essentially, I just show you how to detect when two objects collide, but I didn't go into the details of how they would physically behave once they hit and bounce off of each other. And while we can do that from scratch, I thought, why not use a physics library, specifically matter.js? Not only it is a lot less work, but the people that make these libraries have done such amazing work already, so why not use that and build off of something that is already quite strong. We also will be learning how to integrate an external library into our sketch, as well as learning how to read the documentation. So out of all the physics library, why matter.js? There are actually many great physics library out there, and you can choose whichever one you want. But I thought that we would start with matter.js because it is catered towards web-based interactive experiences, and I thought that that is a good one for us to start with. So what is matter.js? Matter.js is a 2D physics library that is specifically designed to simulate rigid bodies, meaning objects that do not deform under forces. It was created by Liam Brummett, and the engine focuses on providing realistic physical behavior such as collisions, gravity, and friction between rigid objects like rectangles, circles, and polygons, and it is ideal for web-based simulations, games, and interactive experiences. This video is the first of a few in this series where we'll be exploring matter.js. Specifically in this one, I'll walk you through the basic building blocks, show you how to set up and use matter.js, and also integrate it with P5 sketches, and then we'll wrap it up with a very simple example. If you want to learn more about matter.js, I recommend that you check out their website with its full documentation, as well as Daniel Schiffman's Nature of Code book, specifically Chapter 6 on physics simulations. Alright, with that introduction, let's get started. What are the key building blocks of matter.js? In this video, we'll be talking about the 7 key components: engine, world, body, bodies, composite, render, and runner. So the first component is engine, and engine is the heart of the system. It is what manages the physics simulations by updating the state of objects over time. The engine is essential for driving the simulation forward, ensuring that all physical behaviors like gravity, friction, and movement are accurately applied to the objects in the world. And this leads us to the next component, world. So the world is the container for all objects, bodies, and constraints. It acts as the environment where the physics simulation takes place. All bodies must be added to the world for the physics to be affected on them. So without being added to the world, then they will not be experiencing any physical behaviors. So what is a body? A body is a single physical object in the physics simulation. It has its own shape and its own properties. And shapes, the examples are rectangles, circles, and polygons. And for properties, these are mass, position, velocity, angle, and many more. A body interacts with each other based on the physics rules defined by the engine, and a body can either be static like ground or dynamic like a moving ball. There's body and then there's bodies. So in matter.js, bodies is not its own class, it's a namespace. And a namespace is a naming container that groups related methods, properties, or objects together under a common name, making it easy to create a specific type of body. And that is exactly how we're going to create a body, either a rectangle, a circle, or a polygon. So when we call body.rectangle, we create a new body object with specific shapes and default properties. And these properties can be modified once a body is created, and I'll show you how to do that later on. Next, composite. Composite is a collection of bodies and constraints that behave and can be managed as a single group. And we have touched on what a body is already, but not what a constraint is. But a constraint is essentially how we connect things together inside the world. A composite can contain multiple bodies, constraints, and even other composites, allowing for hierarchical structures. And as a matter of fact, pun intended, in matter.js, there is no dedicated world class. The world is simply the most top-level composite in the hierarchy that contains all objects and constraints in the simulation. All right, let's go to the last two components, render and runner. Render is a module inside matter.js that is responsible for visualizing the physics simulation. And I'm going to show you how to use this built-in render, but ultimately we're going to be using p5.js to actually visualize things on the screen. And runner is how we update the engine at a fixed interval, and it is usually tied to a specific frame rate. And similar to render, I will be showing you how to use the runner module, but eventually we actually will be updating the engine inside the draw function. Okay, let's start coding. So first, we're going to look at the matter.js website. All right, we're going to start by going to documentation. So as you can see here, these are the main modules inside this library, and we have touched upon many of these components already. So these are actually the ones that we're going to be working with right now. All right, I'm actually going to go to get started, and it opens up this GitHub page. So first, we need to download the latest build or get the release version and include it in the script in your web page. So instead of downloading it and put it inside a local file, what we're going to do is that we're going to reference it to a CDN. A CDN is short for Content Delivery Network, which is a network of servers used for hosting files. And if you come to index.html file here, you can see that that is how we reference the P5 library as well. So I actually have copied the script tag already for matter.js, so you can just come and copy what I have right now. And as you can see here, this is version 0.20.0, which is the most current version at the time of the recording. And then once we reference the library, the next thing that I want to do is that I want to actually follow their minimal example here. But I'm not actually going to follow it to a T, and that is because this documentation is written back in December of 2021. So there are a few things that I want to change. Not much, but stuff like, not using var here and not actually creating the module aliases this way. As you can see here, the main modules, engine, render, runner, body, composite, are all being organized using matter.js in front. And this is actually called a namespace. A namespace is actually commonly used in JavaScript library to prevent any potential collisions between names. Let's say that you have multiple libraries integrated into your program, or you have just many different parts that might potentially have similar or the same names. By putting a namespace in front of your classes engine like this, we know that this engine class is coming from matter.js. But to avoid having to type matter.engine repeatedly, you can create what is called an alias. And it does that for all of them, right? Matter.render equals to render, runner equals to matter.runner, bodies equal to matters.bodies, and so on. But instead of having to define each of these aliases individually, we're going to approach it a different way. And this way is called object destructuring. And we're also not going to be using var or even let that we have been using. We're going to use const, C-O-N-S-T for constant. And that is to make sure that we cannot override the variable engine later on in the program and risk breaking everything. Right, so let's start with that. So we integrated the library here. And then next, what we want to do is we're going to start with const. And then a curly bracket. Then I'm going to put all the key components. So we have engine, body, bodies, composite, render, runner. I think that's it. And we set it equals to matter. And as I mentioned before, world is not actually its own class. It is just a top level composite. Let's click run. Great. And then this first step here, we're only going to be using P5 to draw the canvas, but nothing else. So what I'm going to do is I'm going to delete the draw function. And we're not actually going to be creating canvas using create canvas here. So I'm going to delete that and actually put in no canvas. All right, so we just have a blank slate here. Next, what we're going to do is that we're going to create an engine. And I want you to notice here that case matters, right? So we create a variable engine with a capital E, but we can also create a variable called engine with a lowercase e. So let's do that. So what I'm going to do is I'm going to define engine up here, engine, and then inside setup, we're going to set engine to engine.create, and this is how we create an engine. Run. Nothing happens. We just created an engine, right? Next, how about we create a renderer? All right, so let's copy and paste this inside here. And I'm actually going to define render out here. So as you can see here, render.create method. Ooh, you can put in stuff, you can put stuff inside. So why don't we go to their documentation page, render. And underneath here, you can see matter.render.create. And then options creates a new renderer. The options parameter is an object that specifies any properties you wish to override the defaults. And if you look here, in the example code, they have element and engine. And it just seems like element is probably just tells you where you want your canvas to be. And then engine is which engine are we working with, right? So we can look at it again. Let's go to, how about element? A reference to the element where the canvas is to be inserted. All right, so where is it being inserted? It is being inserted in the HTML body, right? And then engine is just engine. So if I click run, nothing happens right now. And that is because if you go back here, you can see that we need to run the renderer. Yeah. Okay, so let's try that. Okay, so I guess the default color is black and the size is quite large for us right now. And so I happen to know that we can also change the size of the canvas. So here, if you go to options, .width, you can see that you can change the width in pixels here, and same for height. Options.height, and you can see that it's options, it's render.options.height. So how we are going to write it is actually options colon, is that a colon? And then, oh, you also need a comma between each of these options, and then we put in width, and let's set it to 400 by 400, the size that we like to work with. Let's try to click run. Yay! Okay, so now we have a canvas of the size 400 by 400, and this is us rendering it using matter.js, not p5 at all, okay? How about we start to create some bodies? So they create two boxes here and a ground. And you can see that they use the body's namespace, right, to create a rectangle body that comes with its own default properties. And okay, let's start with that. So I'm going to go to bodies and go to rectangle. Right, so matter.bodies.rectangle, you put in x and y and then width and height. And I guess you can provide some options too, but we're going to do just 4 of these, which is the same as how they do it here. So let box is equals to bodies.rectangle. And then how about we do it at 100 by 100? Let's do the size of 50 by 50. Let's click run. I don't see anything on here, even though we already ran the render. Why is that? And that is because we need to add the bodies into the world, right? So we can do that using a method add inside composite here. And the things that we put inside here. So what is this? Engine.world, and then this is just the object that you want to add. Engine.world is a composite, as I told you before, right? World is the most top level composite, and you can actually check that by going to engine, and then you do world. Let's see, engine.world. And engine.world is a composite. All right. So I didn't know how to use matter.js before, but you just look at the documentation and just kind of play around. And now we know that we just do composite.add, and then you want to add it to the world, right? So it was what? Engine.world, comma, box. Ta-da! We have the box at 100 by 100. But let's check something. So if we do 0, 0, all right, it's here. And this is for us to verify where is the x and y coordinate, and it is at the middle of the rectangle. So this is good to know because we're going to be using P5 to render everything, right? So now we know that we need to use the rect mode center when we draw out the rectangles. All right, so let's set it back to 100 by 100. But why is it not moving? What did we miss? Which is the last part, the runner, which is the component that actually updates the simulation, right? So let's just copy everything here. Let's put it here. I actually am going to define runner out here. And then after we created this runner object, then we run it, right? Run the runner in this engine. Run. And then the physics is added, basically just gravity onto this box. Okay, you saw here that they created 2 boxes and a ground. And then inside ground, there's this thing that they put inside this curly bracket. This is one of the options that you can define inside a body. And it basically set the ground to be static instead of moving, which is the default option, I guess. So let's create ground. Oops. So let ground, actually let's put it down here. And then ground is going to be bodies.rectangle as well. And then we already know that it is in the middle point, right? The x and y, so it's going to be 200. I don't think we can say width. Let's just try it. Width, and let's do height. Actually, let's do height minus 100. How about we do size of width and then size of 10. Okay. Oh, it didn't work. I'm not sure if it's because of this or because we have not actually added it to the world. So to add multiple objects, we need it inside this bracket because it's an array. So we're going to add ground. Oh, I guess we can just define it as width and height here, but we forget what to set is static to be true. I guess this didn't work. So we actually want to, let's just hard code it for now. I'm going to do All right, so now the box stops on here. Great. All right, so before we move to see how we can connect it with P5, I want to do two more things. The first one is that I want to change some properties of this box. So what properties should we change? So I want to go back to body and then, body. And actually, I want to set its angular velocity. Sets the current rotational velocity of the body. It affects the body angular speed. So this is how we're going to do it. So we do it, how about we do it right after box here. So body.set angular velocity. Inside here, we put the body that we want, which is box, and then the velocity, let's do 0.2. Great. All right. So that's how you do it. You can change the properties after the body is created. Now, how about we try two more shapes? The next one, how about we do a circle? And circle is equals to bodies.circle. So let's see what is the arguments we need to provide. So x, y, and radius. We're not going to look at options yet. Let's just do these three. So x, y, let's do 200 by, how about 0? And do a radius of 30. And then don't forget to add it to here, right? Ta-da! All right, what if, let's make it smaller. And then I'm actually going to put it like almost right on top of the box to see how they interact. Right, so now both of these bodies have the physics, the default physical properties applied to them. Perfect. All right, let's go to the last one. How about polygon? So a polygon is equals to bodies.polygon. What do we need? Okay. X, Y, sides, and radius. So before we go there, you can see that there are other ways that you can create bodies. You can do it this way using from vertices by providing all of the points. So this, you can create different shapes, right? And I think you can do a rectangle. We did that. You can do a trapezoid. So play around. All right, so now, what was it? X, I think it's X, Y, sides, and radius. X, Y, how about we do 0? Let's do 10. X, Y, let's do 30. Sides, how about we do 6 sides? And then radius, let's do 50. And we're going to add it to our world. And it's just like, it doesn't rotate at all, right? Actually, let's move this to the right a bit. It rotated now because it hit another body. But you can also set the angular velocity for the polygon, right? Actually, what if I try to, I wonder if I can do this. Box and polygon. I don't think that works. The box didn't move. So I think you need to do it separately like this. Yeah. Perfect. Okay. So now the polygon is gone. All right. So now let's connect it with P5. And as I mentioned before, we will not need render and runner anymore. I'm going to also share the sketch, but actually let's just duplicate it.
A few moments later.
All right, so when you didn't look, I deleted render and runner modules and also all the other bodies that are not a box. Also, we're not going to use no canvas here anymore. We're going to create a regular canvas that we usually create, right? And let's set a size to 400 by 400. So essentially, we're going to use the matter.js to apply all the physical behaviors, but we're going to render it, so visualize it using p5, and also we're going to update the engine inside function draw. So what we need to do is we need to bring back draw, and now what we need is, if you go back to engine here, oops, and update. So we're going to do engine.update engine. So you can see here, delta is the time interval that is set to update the engine. But I think if we just leave it as is, it will be updated based on whatever the draw function interval is, which is 60 frames per second. So engine.update engine, that's how we're going to do it. Let's click run. Oh, box, just box. Oh no, it's box and ground. Yeah. All right, you don't see anything because we haven't drawn anything yet, right? We just updated the engine, but at least there's no error. So let's put the background back to 220. Now I want to see what are the properties of my box. So I tried this, and so if you know, let me know. But if I just print box, I don't actually see anything. But if I do, for example, like box dot some property, let's do position, then I can see these values. So I'm not sure why I can't see that the rest of the properties just by printing out box, but it's okay. What we can do is we can just come to body, and you can just look at the properties that you want, right? Like for example, like body.angle, body.position that I just printed out, body.angular speed, and so on. All right, so now that we have these X and Y position, what we're going to do is that, how about we just set X to be equals to box.position dot X, and then Y to be equals to box.position.y, and then we're just going to draw it out, right? And we already know that the X and Y coordinates here is the center, so we need to also change the rect mode to center. And then X, Y, let's do the size of 50. All right, and it stops here. We haven't drawn the ground yet. All right, so you might be wondering why I put in 50 here instead of putting like the box properties, but I think inside matter.js, there's no width and height properties, but what they have is actually this thing called bounds, which defines AABB. So let's try and print that out. So if I print out, what is it? Box.bounds, right? What you get is min X and Y and max X and Y. So why don't we try to draw the ground using that? So how about we do, I'm just gonna do ground 0.1 equals to ground dot, I think it's going to be dot bounds dot min dot X. Let's try that. And then we are going to do it 4 times. And this will be 0.2, 0.3, and 0.4, min of Y. And then this is max of X, right? Max of X, and then max of Y. All right, and then we now draw a rectangle using GP1, GP2, GP3, and then GP4. But now these points are not actually with the rect mode of center. It is actually off the rect mode of corners. And this is the mode where you provide 4 points that are the 2 corners, top left and bottom right. And let's try that. All right, looks pretty good, huh? Oh, but you see that? it kind of bounces like this, but it didn't rotate. And that is because why? Because we're actually drawing stuff on P5 now, and we haven't rotated the body here. So why don't we do that? So to do that, we need to use the rotate function, and the rotate function comes with the translate function, right? So basically, we need to rotate around the origin point. So instead of putting x and y here, what we actually need is we need to translate it to this x and y point. And then now we draw it at 0, 0. And then we want to rotate it by a specific angle. And actually, that angle is going to be equals to box.angle, the property that we saw earlier, and it is in radians. All right, let's try this. Whoa. Did you see the ground? That is because when we use transformation functions, we also need to consider whether we want to use the two functions push and pop. And these two functions basically saves the transformation and then return it back to the original default settings before it is called again. Ta-da! All right, now comes the last part. I'm going to create two classes, one for the ground and then one for the rectangles. And then we're going to use mouse press function to create a bunch of boxes inside a boxes array. We're going to come to this arrow here, click the plus sign, and then click create file. And then we're going to create two JavaScript files, right? The first one, how about we call it rect.js? Yeah. And then the second one, let's call it ground.js. All right, let's start with the rect one. Oh, before we writing the class, right, we need to reference the file. So come to index.html and copy these line of codes and then change the name to rect.js and also ground.js. And this is how we integrate a new JavaScript file into the program. Let's start with rect.js. Start with the word class, and then how about we call it rect. Inside the constructor function, we're going to provide a total of how about 4 parameters, x, y, w, and h. And we're going to draw the rectangles in the rect mode center. So we're going to set this dot x to be equals to x. Actually, no, we just need this dot w to be equals to w, and this dot h to be equals to h. And then what we need is basically I'm just going to copy and paste these to here. And what we're going to do is ground is not here, right? Yeah, okay. So 100 and 100 here will be x and y. And then this will be this dot w and then this dot h. And then we need to add it to the worlds, but it's not box, it's this dot, how about we call it body? This dot body and this dot body. And you don't need to set the angular velocity now, but why not? And then let's create a method called display. And in display, what we need is, we need all of this. Right? And instead of box here, it's going to be this dot body, right? And oops, let's see. Okay, this also is going to be this dot body, dot angle xy, and then this will be 0, 0. Okay, and this dot w and then this dot h. This is how we display it. So how about I'm going to comment out the ground first. And we can delete this, and then we just create one box, and box now, we don't need this. Box now will be a new rect at 100 by 100 of size 50 by 50. Run. Oops, we need to also do box.display. Ta-da! And as you can see, because we commented out the ground, as in like the ground is not actually part of the world, so it no longer works. Now, how about we go to ground and do the same thing? So class ground and constructor. And actually, I guess you can create ground as part of the Rect class, but I thought that we do it separately because we're going to be changing the different, or we can change the different properties of the rectangle inside the Rect class later on, right? But we want the same, everything is very similar. So this dot w equals to w, this dot h equals to h, and then we're going to, oh, this is the key difference, right? Because ground is actually static. If static is true, then we want this to be x, y, this dot w, and then this dot h. And then we just do, how about this dot ground? And then inside display, I'm going to use the same rect mode as rectangle. So inside ground here, we don't need angle. Everything else is the same. Oh, and don't forget to add ground to the world, right? So engine.world and then ground. No, this dot ground. And then we're going to create this one ground. So ground is a new ground at, what was it, 200 by 300, size 410. And then delete this. And then ground.display. Oops. This is ground. This is also ground. Run. Okay, the last part that I'm going to do is actually, how about we create a bunch of boxes. So I'm going to change this to an array. We don't want box here anymore. And I'm going to use a function called mouse press, which is going to be called every time we click or we press the mouse, right? And what is it going to do? It is going to add a new box object or rect object at x and y of mouse x and mouse y. Let's do a small size of 20. Instead of displaying it here, we need to go through the for loop of I equals to 0, I less than the size of the box array, I plus plus, and then we just do boxes of I dot display. Boop, 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 boop. All right. Okay, I think this video is probably long enough for the first one, and it gives you a good understanding of how this library works. So in the next video, we'll be making any pixel together. So let's go to that one.